Hello, Professor. So this is our last meeting for the release plan 4. Here is our team. So everybody is present, and we're gonna discuss each task we worked on, and we will demonstrate them also. So let's start for the first one. This clean CSV. This has been done by me, Navdeep, and Charanjit. So Charanjit may start right now. So I'm gonna display here.
Yeah, Professor. So we use this data, but there are like so many rows in data which are missing, which have missing values. So we clean the rows and we use then data after the cleaning and rows of it. So this is all the data you can see we use in the project. Yeah.
So yeah, this was generated from Mokaru, and yeah, as Chanjit said, we had to clean this. This was just one of the tasks. Then we had also, in order to work with the machine learning part, we had to virtualize or create an instance of Linux OS. But instead of using VirtualBox or other softwares, we went with Docker. So Docker, we created a container for TensorFlow and Keras. And as you can see, this is running right now. Uh, just to show you, it's running here. It's basically a Jupyter notebook for Python. We worked on this in this environment. This is our random data.csv, the file we just looked into, this one. And this is the Python library, the Jupyter notebook, sorry. And here is the code for the machine learning part. So as this was for our second task. Then we went also for dialogue training the dialogue flow agent. This was, as you can see, this was a task for Amanpreet, Bhupinderjeet, and Shubhankar. Shubhankar will talk about this right now. So please go ahead.
Hello. So what we did with the dialog flow, we created the model and we were training the model with possibilities of parking, reservation, and also the account settings. We have been training the model, and so we had the integration with Google Dialogflow, which was really helpful. We kept training, and in the training module, we were able to find out the kind of possible things. One unique thing which we did, that we shared this link with all our team members, and we were able to get a lot of feedback, lot of different questions which we monitored manually, and followed by which we allowed it to proceed or not. Soon we will show you the demo of how it is actually working. Keshav, do we have the demo ready to show it?
Oh, yeah, exactly. So if we can launch the application from there. Yeah, so basically this thing, Dialogflow, the agent that we have trained on the front side, it has been integrated in the Android Studio by using the Google's free available SDKs. So here what we are doing, we're gonna input the user inputs that we have taken and anything, and the user can ask the question from the system. And if we let's just say this is a question, if we're gonna send this question to a server, Dialogflow is gonna respond with its option as we can see. So this response has been trained on the Dialogflow side and has been answered by the model itself. So that's how the integration of the Dialogflow as a chatbot working in our application.
Let's try some trickier questions. How about we ask him a question about parking? Let's see what he replies. Nice. What if we use some keywords? Let's say I just want to go with account, maybe. Just type the keyword account and let's see what. Okay, so as you can see that our model has been trained, like it will fetch all the keywords, it will try to analyze what is happening, and it will take you to that particular response directly.
So just keeping it simple and straightforward, typing the keywords gonna help you in a quite effective way. So that's how the model has been trained on the Dialogflow side.
So this was regarding the chatbot. This is an application apart. We didn't integrate right now within Parkit. So as you can see, it's not actually a part of our application Parkit, which is here. It's actually another application for now. So regarding okay, so let's go to the next task. Train TensorFlow model with CSV as input. So in this task, we had this is our random data we showed earlier, and yeah, this is the Jupyter notebook. On this, there were Simarjit, Banka, and me working on this one. Simarjit can give you a brief intro for this.
Uh, yes. So as Charanjit has already mentioned that we have cleaned the CSV file, and Akshay has already mentioned that we created the file. So now I will explain the parts of the file and how it is going to work. So we have almost 5 columns for this sheet that we're using CSV file. So each column is representing a field that we are going to use while predicting the data. So like first is representing day. So every column has only numerical data so that it will be easy to predict and get the data response from the um, machine learning algorithm. So like in the first row, if we say that it's 4 that represents the day Wednesday, and there is 1337 that represents the time, that the second row in the Excel file that Akshay is showing with this. And then there is 3 that determines like which type of weather it has. And next is 9, type. So type is basically the list of types in the database that we already have, the place types. It can be airport, it can be parking, train station, or school, or hospitals. So next will represent the status, that if the place is open or closed, or if it is not available. So in the first record it shows 3, so it's not available. And for a particular user, whether he can find that location or not, that was the final output. If it's 1, then it is yes. If it's 2, then it's no. So we are using these parameters to get the output from the machine learning algorithm.
Yeah. So just to add another thing to this is here you can see that this is our X, which means our feature data, and this is our Y. So basically the last column of our CSV. And yeah, that was all for the training part. Next, I mean, we did train. This is our structure. We will include this file inside our drive. uh, so basically we are dividing here the data into sizes, and then we create the model and all. So let's go to the next task. Test evaluate TensorFlow model.
Uh,
This will talk. Pinderjit will clear out for us this one.
so the feed testing data is divided into 2 parts. The 80% of the data is used for the training, and the rest 20% is used for the testing. The rest 20% data, which is completely a new thing to train the model.
Yeah. So yeah. Okay. So 20% exactly. It's yeah. As she shared is it's basically unseen data for the model. I mean, this split has been done through Python. It's not it's actually random. So when it divides, it takes randomly 20% of this CSV file. Going forward, we have test TensorFlow model on real examples. So on this part, Shivam, Simarjit, and Amanpreet worked on this task, and Amanpreet can can talk about his task here.
Yeah, hi. As Bhupendrajit explained that the data was divided into two parts, 80% was training data and 20% was testing data. That was totally the data which was unseen there. So we, for the unseen data, we search something, the data which was the real time data that we compared with this training data to test that whether this algorithm is working properly or not. So that was done by the Jupyter, and the results were quite good. And yeah, that's it.
As you can see, I mean, as the data was most of that was random, you can see that if we go in the end, the final test results of a loss of
Yeah.
0.78 and an accuracy of 0.5, which was actually predictable because this is random data. So basically, every column of this data is randomly generated, so we cannot really predict if if we are going to find a parking spot there or not. And in fact, that is even that's also what our model says, because 50% actually means that either you can find it or you cannot find it. So it doesn't really make a choice for you in this case because of the random data. So this was our last task we worked on. We also updated on GitHub. So as you can see, all of our issues are now closed. The last one were here in enhancement, test, evaluate, train TensorFlow model with dummy data, and all these, which are also inside our technical documentation. So yeah, that's all. If we have any input, I don't think so. Do we have any other inputs, guys? Anything else to say?
No, that's okay, I guess.
That's all. Okay, so I'm gonna stop sharing my screen. Thank you. Bye.
Thank you so much.
Thank you.
Thank you.
Thank you, sir.
Thank you.
Thank you.